A very good day I bid to Prof. Madhya, Dr. Maryam. My name is Sornavalmil Ichmanan and my matrix number is 217019. Today I'll be presenting about oscillators in communication systems for our course EE 3532 Communication Engineering. First, let me talk about the introduction. What is an oscillator? An oscillator is an electronic circuit that produces a continuous repeated waveform without an external input signal. Its function is to convert DC to AC, and it is used to generate sinusoidal, square, or triangular waveforms. The importance of the oscillator in communication is for it is used in signal generation. It is an RF carrier, frequency synthesis, and also clock signals in digital systems. Now let's take a look at the application. Oscillators are used to generate signals as an audio synthesizer at frequency 20 Hz and below, as audio oscillator range of 20 Hz to 20 kHz, as a local oscillator to transform the RF signals to IF signals in a receiver, to generate the radio frequency RF carrier in a transmitter range from 100 kHz to 100 GHz, as sweep circuits in TV sets and CRO, and to generate clocks in digital systems. Now, let's take a look at the types of oscillators. There are four types. The first is LC oscillators. It is used at RF, includes Hartley and Colespeed oscillators. Second is RC oscillators. It is stable at lower frequencies, such as Greenwich oscillators. Third is crystal oscillators. It has high frequency stability and it is used in mobile and satellite communications. Fourth and final is voltage control oscillators, known as VCOs. It is used in PLLS and modulation circuits. Now let's take a look at the circuit of an oscillator. This is the circuit of a general oscillator. An oscillator is an amplifier with a positive feedback. The closed loop gain is AF equals to VO over VI equals to A over 1 minus A beta. Now this is the circuit of a Greenwich oscillator. It is a low frequency oscillator which ranges from a few kilohertz to only 1 megahertz. The voltage gain is AV equals to 1 plus R2 over R1 which equals to 3. As you can see, I've also provided the output graph of the Greenwich oscillator. If we want a oscillator with more than 1 megahertz, we need to design an LC oscillator, more specifically, maybe an Hartley oscillator, which can adapt to more than 1 megahertz of frequency. This is the circuit of a phase shift oscillator. The phase shift oscillator utilizes three RC circuits to provide 180-degree phase shift that, when coupled with 180 degree of the op-amp itself, provides the necessary feedback to sustain oscillations. The gain must be at least 29 to maintain the oscillations. The frequency of resonance for this type is similar to any RC circuit oscillator, where Fr equals to 1 over 2 pi square root 6 times with RC. Now I'll be presenting about the modern implementation of the oscillators, where it is used today. Oscillators are used in 5G transceivers, GPS systems, SDR, known as software defined radios, and also IoT devices with RF communications. Example of this modern implementation is the use of PLL with VCO in RF front end of 5G chipsets. And it also includes a real-life image or chip block diagram. As an example, Qualcomm or MediaTek RFIC. Now, let's see how oscillators have evolved and improved. During the early days, LC and RC oscillators were with limited stability. As for the improvements, crystal oscillators from 1930s onward were um, were introduced. Temperature compensated and oven controller oscillators TCXO and OCXO were also introduced. MEM-based oscillators, and fourth is modern CMOS integrated VCOs for gigahertz ranges, and the trend is miniaturization, stability, and integrations into SOCs. Finally, let's take a look at the key takeaways on oscillators. Oscillators are vital in communication systems for generating continuous waveforms, especially for timing and frequency generation. Common types include LC, RC, crystal, and VCOs oscillators, each used based on frequency ranges and stability needs. Modern applications rely on highly integrated oscillators found in 5G, GPS, Wi Fi, and IoT devices. Over time, oscillators technology has evolved to offer better frequency stability, compact size, and lower power consumption. Oscillators remain a fundamental building block in both analog and digital communication systems. So, that is all from me. I hope you have enjoyed my presentation about the oscillators. Thank you.